Good morning to one and all attending the live classes, or I can say attending the video. Okay, so in our previous class what we have discussed was how the radiations were emitting out from the radioactive element. And the radioactive process was discovered by Henry Becquerel, and the rays or the radiations which were given out during the process of radioactivity was named as Becquerel rays. But later on the particular names were given to all the radiations. And then we have already learned that on the basis of the emissions or on the basis of the reactions of the rays in electric and magnetic field, Rutherford studied some of the characteristics related to the rays. Okay. So now let us have the properties of each and every rays that are emitted out during the radioactivity. So the first topic of today is the properties of alpha rays. What are the properties of alpha rays which is emitted out in the process of radioactivity? So from the experiment of Rutherford, it was clear to us that when we had alpha rays, it was attracting towards the negative field. It was attracting towards the negative field, and from there itself we concluded that alpha rays are positive in nature. They have positive charge with it, or they are positively electrified, okay, or they carry positive charge with it. Okay, so it was one of the property. The next is the representation of alpha rays. If I say alpha ray is emitted out during any radioactivity process, so how we are going to represent those alpha ray? Basically, alpha ray is represented by the symbol 2He4. 2He4. I know this is of helium. So this is representing alpha rays. Whenever 2He4 is given, we consider it as alpha rays, where atomic number is 2, mass number is 4. Atomic number will give you the number of protons and electrons, and 4 means protons plus neutrons. Now since we have 2 protons, and protons plus neutron is equals to 4. So what will be the number of neutrons? This will be 4 minus 2. That is mass number minus atomic number. And this proton is always equals to the number of electron. So basically in alpha particle the representation is in the form of 2He4, which has 2 protons, 2 electrons and 2 neutrons. And on the basis of the number of electrons we make the electronic configuration. I hope the first property is clear. Now the second property is regarding its mass and charge which it carries. The mass of alpha particle is generally 4 times the mass of proton. The mass of alpha particle is generally 4 times the mass of proton. And we have already discussed in the starting of the chapter what was the mass of proton. The mass of proton was equals to 1.67 into 10 to the power minus 27 kg. This was the mass of proton. Now we have multiplied it by 4. And we have 6.68 into 10 to the power minus 27 kg, which is the mass of alpha rays, which is 4 times the mass of proton. Now what about the charge? We know that the proton carries a charge of 1.6 into 10 to the power minus 19 coulomb. So the charge carried by alpha particle is just the double of the charge of proton. The mass is 4 times of proton and the charge is 2 times of protons. I hope this is the second property. Let us come and discuss the third property. The third property is regarding the speed of alpha rays. Because alpha particle, and it is a particle, so it might be moving with some of the speed. So the speed of alpha particle is in the order of 10 to the power 7 meter per second. What does it mean? Like I say, any magnitude is there, 3, 4, 6, any number multiplied by like we have the speed of light as 3 into 10 to the power 8. The same is the speed of alpha rays, but it is not in the order of 10 to the power 8. It is in the order of 10 to the power 7 meter per second. So this is the speed of alpha rays. Now the fourth is regarding the ionization energy of alpha particles. See, what do you mean by ionization energy or ionization power? Ionization energy is the tendency of the particle that when it is dissolved in water, so it completely ionizes and breaks into positive and negative ions. Or the next definition what we can understand from the ionization energy is the energy of electron, because we know that in atom, in each and every particle, the atom is generally holding the electrons. So the electron is not feasible to go out from its orbit. So the energy required by the electron to overcome that force so that it can jump out of its atom. So that is ionization energy. So basically the ionization energy of alpha particle is very large. Okay, so ionization energy of alpha particle is very large. In fact, it is more than beta and gamma particle also. The next is related to penetration power. Penetration means एक मीडियम से दूसरे मीडियम में पार होके जाना. क्योंकि इसकी आयनाइजेशन पावर ज़्यादा है, ये इजीली आयनाइज हो जाता है, ये ब्रेक हो जाता है, सो इसका पेनिट्रेशन बहुत ही कम है क्योंकि मोस्ट ऑफ द एनर्जी इज स्कैटर्ड बाय ड्यूरिंग द आयनाइजेशन, सो इट कैन नॉट हैव मच एनर्जी टू पेनिट्रेट फ्रॉम वन मीडियम टू अनदर. सो जितना ज़्यादा आयनाइजेशन एनर्जी उतना ही मिनिमम पेनिट्रेटिंग पावर, उतनी ही मिनिमम पेनिट्रेटिंग पावर. I hope this is clear. So maximum the ionization energy, minimum will be the penetrating power. Sixth, we have already learned from this experiment that whenever we are bringing any negative or positive electric field and bringing the alpha rays to it, it is getting deflected. It is getting deflected. But since the mass of alpha particle is 4 times the mass of proton, which is very large, so it is not deflected to that much extent. ये डिफ्लेक्ट होता है बट इसका मास ज़्यादा होता है, तो ये ज़्यादा डिफ्लेक्ट या इधर उधर ज़्यादा डिफ्लेक्ट नहीं होता क्योंकि ये भारी होता है मास. ओके, the next is, it is already given in the book that it affects a photographic plate. photographic plate का मतलब जैसे whenever we were using cameras, तो हमारे पास रील होती थी, जो कार्बन कॉपीज जिसे हम कहते थे, रील होती थी, उससे हम फोटोज निकाल सकते थे. तो सिमिलरली इज अ फोटोग्राफिक प्लेट. सो व्हेनेवर अल्फा पार्टिकल्स स्ट्राइक ऑन फोटोग्राफिक प्लेट, इट अफेक्ट्स इट, इट गिव्स सम इमेजेस. इट आल्सो क्रिएट फ्लोरेसेंस व्हेन इट strikes on fluorescent material. Fluorescent material means it absorbs the light, it absorbs the visible light and or any light and gives out the visible radiations. So whenever it falls on the fluorescent material, it emits out the color. Okay. The next property is, since the mass was very large, so we know kinetic energy is half mv square, momentum is mass into velocity. So since the mass is very large, kinetic energy and momentum is also very large. Okay, and the next is regarding the biological damages. Yes, it affects our body. It also has some of the effects on our body and thus produces a biological damage. Okay, and the last is, alpha particle is scattered while it is falling upon a gold foil, and this experiment was done by Sir Rutherford, and from this experiment of alpha scattering particles, he concluded the discovery of nucleus. So these are some of the properties. In our next video, we will discuss the property of beta and gamma rays. Thank you.